All right. Hey there everyone, my name is Hitesh and welcome back to the YouTube channel, and we're continuing with our backend series. This video specifically talks about the Mongoose and especially the hooks of the Mongoose. This is a very special topic and is considered as a moderately advanced kind of a thing, but it's super easy to work on with. You don't have to worry, and I'll walk you through with each step of what we are learning, why we are learning, what's the implementation of it, and what could be the alternative for this one. So let me first share the screen with all of you. So what we are studying here is the middleware in the Mongoose. By the way, you can just do a quick search on Mongoose hooks, which is exactly the topics. And in this, you want to search for the middleware. Now, what is the middleware? Do we have a light mode for this one or dark mode? No, we don't have. Sadly, you have to go through with me on this light, bright screen. Anyways, so one of the key thing here is the middleware. And middleware is something that happens in between. So maybe the request is going on to getting saved in the database, and just before it's getting saved, I want to perform some tasks. These are middlewares. And Mongoose provides you the pre-hooks and the post-hooks as well. Pre-hooks, just before saving the database, it's being sent from the code base that, hey, go ahead and save it into the database. Just before saving it, you can perform some additional operation. And similarly, we have post hooks as well. Just after the saving in the database, before it returns the response, we will add some functionality. So it depends on you what you want to do. So as we can see, we have here some of the pre-hooks, we have post hooks, we have asynchronous post hooks, save validate hooks. There are so many hooks that works on with that. Now we will work on these one of these hooks to for our functionality part. Not only that, we will also work on the methods as well. So MongoDB actually provides you methods as well. I can just search for it. And API method, hopefully that is the one. Yeah, so on the schema itself, you can actually apply some of the methods as well. So schema.method, I hope there's example. No, there's not good example up here. So this is the example that we have to go through, but I'll walk you through with a better example. So just like here, you can see that we have designed a schema of the kitty. Whatever the data is inside the schema doesn't really matter. On this schema, you can actually add a method, and this method is now going to be a part of the Mongoose as well. For example, whenever you want to make a query from the database, you write whatever the schema name is, let's just say user model. So user dot find by ID. So you are looking for a account or a record based on an ID, or find by email or find, and then you mention the email. Similarly, the way how the find actually comes to you, you can design your own methods and they will be considered as a part of schema itself. So these are really, really nice, and we can simply use them. So both of these knowledge, you can read more about them, but I highly recommend you watch the video first so that we can go through. We'll come back onto this part a little bit later. And first, let's open up the source, and this time we want to go into the models and inside the user model. Now, majority of the time you want to write all the functionality in the controller itself, but there are special cases and special times when you want to add some of these methods because they are so much attached to only the model itself that you don't want to put them into the controllers. You want to attach them to the models. This is one such case, and we're going to handle that right here. All right, so go ahead and open up your user model, and let's handle the things one by one here so that we can see how is it going on. Now, one of the common thing that we want to do is every single time we are storing this user, we want to encrypt the password. Storing the clear text password is absolutely a no-no. That's a really wrong practice. So it is 100% that we want to encrypt the password. How you want to encrypt that? There are a lot of ways how you can encrypt that. You can use the crypto modules of the node inbuilt, but most of the time you will notice that people actually use one such library, which I'll walk you through as well. There is one such npm package known as bcrypt. There are two versions of it, the bcrypt and the bcrypt.js. Totally up to you which one you want to use. This one is equally popular, and this is really nice. And there's another one as well. This is bcrypt.js. So you can use bcrypt.js. The version and the functionality is almost same in each one of them. There is no big deal like you want to use one over the other. This was published 7 years ago. This was published 10 months ago. So which one you want to pick up, it's up to you. And both of them are fairly usable. I'll go ahead and use this one, bcrypt. Let's go ahead and work with that. So close this and paste it and bcrypt. So the first part is done, the bcrypt, and there we go. A lot of deprecated warning, but none of them is going to impact us. We can verify that into package.json and we can see, yep, bcrypt is installed. Now coming up onto the user model, how we want to do that. This makes sense that password should be stored in the database in the encrypted format. So just before saving the details into the password, we want to encrypt them. So this is a classic case that user schema, just remember exactly the docs, how we followed user schema. There they called it as schema. Here we are calling it as user schema. And we want to run a simple hook, which is a pre-hook. By the way, there is a post hook as well in case you want to work with. I will be working with the pre-hooks. Now pre-hooks wants you to say that before saving, obviously that's only the pre-hook we have, but it's the event that we are triggering. So we will be triggering the save event, and then we want to write the function. Here my recommendation always and always is never use arrow functions here. You will face a lot of troubles because we need the context of this many times. So we'll go ahead and say async, and we'll use a function, and this function all the time 100% time requires next. All these middlewares that you're writing, they need some next, because request, response, and the third parameter is the next. Next is the way to pass on your request from one middleware to the next middleware to the next middleware, or to finally wherever it needs to go. So next activity is super important. Once you're done with this, the step one that always you should go for is next. This will either pass it on to the next pre-hook, next middleware, or wherever it needs to go. So this is a standard procedure. Once I'm done with this, then I want to encrypt the password. Encrypting the password is super easy. Since I'm using the classic function, I have access to this. Now this keyword, since this is a hook being onto the schema, so whoever is saving this document in our database, this has an access to all these fields: username, email, full name. You can access any one of them by just calling this. I will say this dot password. And I want to update this password. How will I update this? I will be using bcrypt, and we didn't import the bcrypt. So let's go ahead and first import the bcrypt. I think we'll import it up here. Import bcrypt from bcrypt. There we go, and looks good. We don't need to have a JS or anything. All right. So how the bcrypt will encrypt the password? Super simple. Bcrypt, and it has a method that says hash. And by the way, you can read more about them in the docs as well, but it is super simple. It just hashed the password. Now, while hashing the password, you have to say, what am I hashing? I'm hashing the user's password, and this is important. You don't hash any random thing. You are hashing the user's given password. That is the password that is coming to me. I'm just updating that variable. And I'll be updating it with the 10 rounds. This is a number of salts or rounds. I don't want to go too much into the cryptography, but these are the number of rounds through which the algorithm goes through. 10 is pretty good and pretty standard, but if you go with Ruby on Rails or something, they actually by default, I guess, do 12 rounds, but we are fine with the 10 round. These are pretty decent round. All right. So there we go. Our password is encrypted, but there is one more problem with it. So we don't want to run all this password, this line of code at line number 53 all the time. We want to run it when things are not being modified. So maybe you are updating, let's just say username, or maybe you are updating a full name. This will run every single time. So we don't want that. So what we can do is we can simply run a classic condition case here. We can say this dot, and this has access of one more thing, which is known as modified. This will notify whether the things are modified, which field you are looking up for modified. And yes, you have to give it a string, not a syntax that I'm a big fan of it. Now this will say that this will, if this is modifying the password field, then only I want to encrypt. But I can use another logic. I can say if this field is not being modified, the password field is not modified, then just go ahead and say return next. There we go. So we are exiting the function if the field is, if the modified field is not password, if we are not updating the password, because if you look at the logic, the password should only be updated at the time of save or at the time of updating the password, not any time else. So if the modified field is not password, then hey, I am not interested in running this piece of code. You just go ahead and return it. But if the modified field is password, if you are updating the password, obviously will send me the password in clear text format. In that case, I'll go ahead and run this code. Another advantage is that we are saving it. For the first time when you are saving it, you are not modifying it. So this will also run at the time of save as well. So if that is the confusion, there you go. Now that is clear, because first time when you're saving it, you are not modifying an existing field, you are saving it. So your code will never run into this piece of code. So I hope that makes sense, and that is now absolutely clear. So there we go. We have learned about how the things actually goes and work with that. Now, this is all good, but once the user's password is there, now nobody knows the password. It's all encrypted. So we have to use the bcrypt package again so that we can compare the password, whether the user's entered password is the exactly same password that we are going through. So what we can do is we can define some methods. So user schema, you saw this dot prototype dot method, and if you have studied the JavaScript, you never write the prototype, you just directly write the method name, classic 101 JavaScript. And same goes up here. So we can just go ahead and use this method, no, not method, methods, because there's a long list of methods that can go into this one. And the first method that I'll say is going to be is password correct. So this method, what it will do, it will take the user's password, it will take the password from the database as well, and will try to match it whether they are equal or not. But you might be wondering that, hey, the database password is encrypted. The password that user is sending us is in the clear text. Yeah, that's the easy part. The easy part is you can encrypt again the password provided by the user in the clear text and match it whether the encrypted password is same. But we don't have to do this manually, although that's possible, but bcrypt makes our life a little bit easier in that case. So I can just go ahead and write a method for this one. So there we go, function, because I want to access the password. Whoever is calling this method needs to provide me the password, otherwise how will I compare for that one? And here I can just go ahead and ask bcrypt that, hey bcrypt, do a comparison for me. And bcrypt does all the magic behind the scene. You just pass on two things to it, the password, which is clear text password that is coming up to me, and I'll say this dot password. And I don't have to tell the bcrypt that how many rounds are there and all these things. It knows this thing because this is already being there. So this is a little magic it does behind the scene. The only new thing that you have to remember here is it is await, because it's a long process. Encryptions do take time. It's a compute heavy thing. And after that, what we can do is we can simply go ahead and return this. Now, once we return this bcrypt.compare, it will return me either a true or false based on what is the result. So pretty simple work to do. But now I have a method directly on my schema, just like .find, find by email, and more methods that we are going to learn. These are like database queries. We have another method which is password correct. Now, similar to this, whenever you are storing a user and you are saying that, hey, you are now signed up, now you are logged in, what is the proof that user is logged in? Yeah, valid question. Another thing that we want to do is whenever a user successfully gets logged in, we want to generate some access token and some refresh token. So what are these refresh token and access token, you might be wondering? So we are storing only the refresh token. Let me walk you through with these. So what we're going to be using for this one is JWT tokens. Now there's a nice website around JWT and they walk you through with what all the details are there. Come on, load it up. So JWT, this is a very interesting concept of how we can actually have a stateless authentication with that. It's a pretty flow on its own and requires definitely a video, but you can go ahead and read a little bit from the documentation. This is how a JWT token looks like. It is comprises of different parts. There is a header involved in it, there is a payload involved in it, and there is some verify signature involved in that. Now this verification is based on the secret that we have to put, and based on the secret the modification happens. And in this you can actually add any payload or any data that you can later on extract from this one. So it looks everybody like this, but if you have your own secret, you can actually bring that information back from the user and can ask that, hey, what user you are or what you are doing with that. So all of these information could be extracted. Now, the point is that we need this kind of a system to go on, and we need this JWT tokens to work with that. The JWT token stands for JSON Web Token. And yes, we do have a library for that as well. So if I go ahead and just search for it, JSON Web Token, and here it is, JSON Web Token. This is the library. And we will be able to do all of these things of creation of basically the refresh token and the access token. They both are JWT tokens. The usage is different. The access token, we give the user for a short time that, hey, you take this token. The refresh token are the long-term token, which we store in the database as well. And this allows us to disable the users as well whenever we want that, hey, now you need a fresh login. So we can just flush this out from the database. So I'll walk you through with the phases as well, that how we actually use that in a later on video. Right now, the important part is let's go ahead and install this one. So let's go up here, pretty easy, nothing to be worried on this part. All right, so this installs this. Now let's go ahead and generate the access token. If you remember, the access token is something that we are storing, we are storing only the refresh token, but the process of generating them is almost exactly the same. Let me walk you through with that. So the step one is to generate the access token. Again, same stuff, user schema dot methods, because I want to add another method into this one, which is going to be generate access token. And again, these are going to be obviously JWT token. So we go with the function, and this one don't needs to be an async await. It works directly out of the box, but there is no harm in doing async await. Now what we're going to do is, this is going to be simple, a short-lived access token. So let's go ahead and write it. Short-lived access token, and again JWT token. The short-lived means the expiry time totally depends on you, how much you want to expire it or go with that. So what we're going to do is, we will use this JWT. First we need to import this. So let's go at the very top of it and say I want to bring it in. Import JWT from JSON web token. Okay, so now that we have this, let's go ahead and utilize this. So how we want to import the JSON web token, we can go ahead and look into this usage as well, that hey, there might be usage. There we go, jwt.sign, and then inside this you can do the payload, all the information that you want to store. This is just one example of key value pair, and then the secret. So let's go ahead and just take it, copy that and bring it up here, and there we go. Now let's go ahead and bring it on to the next line so that it makes the life a little bit easier. There we go. So first of all, what all information you want to store into this one. Now this is access token, and this user schema has access of the user as well, the stored user in the database. So this dot, just like it has access to password, and since we are using MongoDB, every single document has an access of _ID. And yes, just like the SQL databases has access to this one, we have access to this .id. And what we want to do is store that into a _ID. So anytime I destructure it or decrypt my token, just like we saw inside the JSON web token, I can grab this information. Here the users can grab the information like sub, name, IAT, and all of this. I will be able to grab the information of _ID. And similarly, I can put more. Usually you just need ID, but for this reference purpose, I'll just inject a little bit more information. Usually in the production, we just store the ID, and whenever we need more information, we can make a database query and get that information. In this case, let's go ahead and add more. There is nothing wrong in that. And we'll say username. This will be this dot username, and let's also access full name. Yeah, not required, but let's grab it. So if you need more information, just go ahead and grab it. Now the next thing is that we have to set up the expiry time as well. If you look onto this one, there is one more thing that we can go ahead and provide that apart from secret. There we go. This is the one. So notice here, this is the data, this is the secret, and the third parameter is expires in. So how much you want the expiry to be, it's totally up to you. I'll just go ahead and have it like this, and we'll add it here. So although I can just hard code these things, but I would love to have these things from the process.env file. So instead of having this hard coded up here, I can just go ahead and say process.env dot, and let's call this one as access token secret, so that we can change it whenever we want. And similarly to this, we'll just go ahead and say, instead of this, this is going to be access token expiry. There we go, expiry. So now we have to just save these variables and have to provide these things. So environment variable, access token goes like this, and the user model goes like this. Copy and paste. There we go. All right, now it's 100% up to you that how much expiry you want to have for the expiry for the access token or refresh token, totally up to you. And as mentioned, access token are short-lived token, but I'm nobody to judge what's the short-lived. For some people, it's just 1 hour. For some people, it's 1 day, up to you. I'll just go ahead and say that I want it to be expiry to be 1 day. Totally up to you. No hard feelings there. And access token secret is usually kept like, as you can see here, we have just the secret here. At some places they mention as she s, which a lot of s, there we go, here it is, like this. But most of the time people love to actually generate such long strings. And again, you can randomly generate it. There are a lot of generators for it. Totally up to you how you want to go with that. I'll go all crazy with this whole long script, which is usually the industry standard, but hey, you got the idea. So there we go. We have gone through with this, that how the user models and all these expiries are being determined. Again, it looks a lot of code, but now that you look at from a step-by-step process, it's not that big. And all we want to do is return this. So hold the code. This will give me a string which looks like this. So I'll get that. So there we go. Told you, it's super, super easy. Now, similarly, this was for the access token, but we also have this refresh token, and I'll walk you through the concept of it in the next video. I will just go ahead and copy and paste this. No harm in copy pasting as long as you know what you're doing. This time it is not a generate access token. We will go ahead and say generate refresh token. REFE, refresh. Come on, I can write that. Refresh token. So there we go. Again, it's exactly the JWT sign token, but as I mentioned, in most of the tokens, these informations are not there, especially not in the refresh token, never ever. Access token might have, might not have. Refresh token only have one information so that we can update the fields. I'll walk you through with the concepts later on. This is what we have payload, but now we don't want to reuse these access token secret and the access token all of this. We want to instead call this as refresh token. So let's click up here, let's click up here, and we want to change this to refresh token. There we go. And again, we have to copy and paste this one. So copy this, go into environment variables, paste it up, refresh token secret and refresh token expiry. Copy that, and we'll go up here and paste that. All right. So again, you can generate these random token values. You can use crypto modules in case you know a little bit of the nodejs. Expiry of these refresh token, these are usually long-lived tokens. So let's just say we can just go ahead and say for 10 days, although it doesn't really matter in this case because we will make the database query. If the refresh token is not even present, then we don't allow the access token to get refreshed. And we can force logout based on these refresh tokens because they are stored in database. Whatever is stored in your database based on this, you can actually forcefully log out the user. Just based on the access token, you cannot actually go ahead and do that. So there we go. We have designed a couple of methods which are pretty beautiful. Returns what we require. You understand each bit of it, each part of it, and that's the beauty of the code. That hey, we not only just have written it, but we truly understand that part. I totally understand at this point you don't understand what's this all refresh token and access token is doing. We will learn with that once we do the login part. In those videos, we will walk through with the Excalibur diagrams that, hey, what goes into database, what goes like that. So we'll do that definitely. But I think this is all it about the methods and the hooks in the Mongoose. And if you need more information, go ahead, read the docs, supplement it with a little bit more research work via the Google, Stack Overflow, or ChatGPT. That's up to you. So that's it for this video. Let's catch up in the next one.